Today I'll explain the IS brake tab standard, show you how to design a tab, and join it into an assembly. This tutorial will show you a few tricks as well as some mistakes that I make, so even if you don't need a tab, it's still good practice to do this exercise. Drawing your tab is good for a few reasons. You can customize the aesthetics of your bike, it's cheaper, laser cut tabs are roughly $4 to $5, and it'll save you time. Because these tabs are designed to your seat stay angles and diameters, they don't require as much filing, bending, and eyeballing to get it to fit. I draw this tab as a separate component. You can choose to draw the tab in your assembly so it updates with your CAD. However, I prefer doing it separately because I can use one tab for several designs. Finally, I draw a pretty ugly tab to save time. As long as you satisfy the critical dimensions of the IS standard, I encourage you to go crazy with the aesthetics. That's part of the fun. The first step of designing an ISO brake tab is to understand the standard. I couldn't find this documentation online, so I created this drawing based on the Shimano frame specifications. There's 5 critical dimensions. The first is the bolt hole diameters. Next are the distance between the dropout center and the bolts. Then after that is the distance between the bolts. And finally, the distance between the dropout face and the rightmost edge of the tab. There's other dimensions that matter. For example, this distance or this distance or even this angle. But they're going to depend on your brake caliper and your brake tab. What I drew here is the most conservative design based on the Shimano specifications. A couple things that can change. This angle between the bolts and the chainstay doesn't really matter. And also just the shape in general can change based on your design. The next step is to figure out how to interface the tab with our dropout and our seat stay. These drawings are based on the other tutorials that I created, the how to draw a mountain bike in 3D and the 2D drawings. You don't have to have those completed to do this design. One thing that I'll say is that these 1.5 Paragon dropouts are offset, which makes this design slightly more complicated. But again, if you can do the more complicated example, you can do the easier concentric dropouts. So I'm going to start by creating a new part. So File, New Design. And I'm just going to draw my dropout. So, or a representation of a dropout. So this is 12 millimeters. And then the Paragon dropout has a 3.5 millimeter offset between the two. So I'll set these two lines equal and I'll dimension it 3.5 millimeters. Make these construction lines. Oops. Select those two, make them construction lines. And then I'll draw the the dropout body, which is 1.5 inches. And then I'm going to draw the seat stay. So I'm going to recreate our seat stay drawing. You can see this is 6 millimeter offset and a 16 millimeter diameter seat stay and a 51 degree angle. So I will create the offset relative to the axle, and this is 6 millimeters. Oh, actually, it's 6 millimeters relative to the center of the dropout. Like I said, these dropouts are a little bit more complicated, but if you can do this, you can do them all. So draw that line, and I'll use the trim tool, cut this, and you see this is not perpendicular, so I'll go to the perpendicular constraints, constrain that. Now I can continue. So this is 6, and this is 51 degrees. these construction lines. And I'm going to use the offset tool to offset this. I want to change selection. Select just this one. And I'll do 16 divided by 2. When I want it on the other side. There we go. So here we have a representation of our dropout and our seat stay based on our drawing here. So I'm going to finish this sketch, and I'm going to rename this one dropout geo. And I'm going to create a new sketch on top of that. And now I can draw my ISO tab. So I'll project this geometry because I want it to touch this dropout. And I want to project this geometry because I want the tab to touch the seat stay. Just really quick, I realized that this line probably needs to be longer. This is just a construction line, so it could be, it's a rough sketch. Go back into here and edit this. All right, so now I have those features. I can start drawing my ISO tab geometry. So we'll start by 2 circles. We'll set them equal to each other. And if you look at the standard, they're 6.2 millimeters in diameter, 51 millimeters, 78.1, 39.9. So start by dimensioning this 6.2 millimeters, and then we'll create construction lines and dimension those and turn these into construction lines. And I believe this one was 51. This one. So you see here, you have to be careful. I'm trying to dimension this line, but this is actually giving me the vertical distance, and I want the parallel distance of the line. So I have to get close to it and kind of pull the cursor down. And you see now it's dimensioning the line itself instead of the vertical distance. Actually, let's redo that. I think there's a better way of doing it. If I just click the line, oh no, never mind. Still happens if I just click the line. All right, so you have to be really careful here. So 39.9. And I believe this was 78.1. Cool. So you see, those are dimensioned, but these lines can still move around, and that's because we haven't constrained the angle yet. So to make things simple, I'm just going to make these 2 parallel between the seat stay and the brake tab. So I use my parallel constraint. I'll click this line, and I'll click our construction line, and we're good. Actually, I can go over to the menu on the left, and I'm going to hide the dropout geo, so it's a little easier to see. And now you see this is the functional geometry that we need to draw the tab around. All right, so let's just do that. Create a circle, set them equal, create a line across, and create a line. So I'm trying to make this tangent so it's a smooth transition. And you see here, if I move this line, you'll see the tangent constraint appear, and the line kind of snaps into place. So that's good there. And do the same for this guy. Tangent. And have it touch here. And then we'll use the trim tool to trim this. And I believe that the recommended radius for this is 6 millimeters. 6.5. And the recommended offset between the center line and the tab is 6.5. Why did it do that? Just delete that. And oh, I know why I did that. Because there's no other way to draw that line. So let's again create a little tangent and another tangent line. You see here, if I drag it here, you'll see a little tangent spot up here. That's good. And then I could trim these away because I don't need these. Nice. So it's kind of, yeah, I had that dimension. So this is kind of arbitrary, the angle. Oh, you see here, this is not tangent. So I'm gonna go to the tangent tool. There you go. And you see how this happens a lot, and you need to know how to fix this in your sketches. But I want to be able to move this line up and down, just like I can change this angle. But for some reason, it's locked in place. And you can see here, it has this perpendicular constraint, which I don't even know what is. For some reason, when I drew the line, I wasn't too careful, and I made it snap to perpendicular between this line and this line, which is not what I want. So if I select this constraint and I delete it, now you can see this line is free to move again, and I can position it where I want. So let's just quickly add some dimensions to this. I'll say this is 120 degrees. So this is 120 degrees. And I'll dimension this to be 140 to start off with. And I'll say this is 60 degrees. Again, we're mostly just tweaking aesthetics at this point. And let's just add a little cutout right here. So I can use the arc tool. Select here, create a little arc. And I'm just gonna leave this undefined because it's really just aesthetics at this point. You can make it fancier or you could keep it simple. It's all fine. And then finally, I want this point to be touching this line. Cool. And now we could finish and we can extrude. So file, what is this? Is it, oh, E. I always hit E, but the extrude tool's here. So you could either use the extrude tool or I hit E and extrudes it and make this 4 millimeters in that direction and click OK. Now finally, this is one tip that I'll give you is I could have drawn a little fillet here in the 2D sketch, but I find that the 2D fillets are pretty buggy. So I always do my fillets in 3D when I can. So I'll select the fillet tool, select this point and let's just give this maybe a 10 millimeter radius. Why didn't I want that? Okay, select edge, edge, and 10. Hit OK. And there you go. Hopefully that fits our drawing. A quick bonus, I'm going to show you how I export this design into a DXF file so I can upload it to a website to get it cut out. So I'm going to create a sketch. I'm going to select the surface of my plate. And now I'm just going to project the geometry. So either create, project include, project, or I could hit P on my keyboard. I'm going to select the face and I'm just going to project all these geometries. So if I hide the bodies, you can see this is the 2D sketch that I want. I'll finish sketch, let it save, and right rename this one to DXF Export. You can name this whatever you want. And I'm going to right click, save as DXF, call this ISO tab. And then now, if I open it, you'll see I have the 2D vector drawing that is used to cut out the tab. Now we can add our tab to our 3D assembly to check for clearances and to see if the tab hits the seat stay in the right spot. Let's go to the menu on the left where we saved our tab, and we can drag it into our 3D assembly. And move this guy a little bit out of the way so I can see it. And I'm going to use the construction drawing of our tab to mate it to our dropout. So if I go to the left to the design tree, expand this for the tab, and then if I go to the sketches, the geo dropout sketch, and I'm going to reveal it, and now I have a reference to mate it to, or to join it to my dropout. So I'm going to hit J for join, hover over the center of the axle, and then try to select this dropout face. So if I hover over here, you'll see that I want to select the center of this axle, the plus in the center, but it's not letting me, it's disappearing as I approach it. And so the trick to selecting that is to hover over the dropout face, hit Control on your keyboard and hold it, and then now it'll save the face that you're working on or trying to join to, and you can move around and select the points. So now I'll select the center of that, and that looks good. And if we go back to our standard, you'll see that the rightmost face needs to be 3.5 millimeters away from the dropout face. So jump back into our assembly. Oh, it saved our joint, but we weren't ready for that. So we'll come down here and edit it. So we go down to our design tree, right click, edit joint. And now I will move this 3.5 millimeters. Cool. You can see here the dropout, or sorry, the brake tab is in the right spot, but it's not really touching the seat stay exactly how we want it. This might be fine for your process. Maybe you could bend the tab or you could weld it, but just for just to show you, I can edit this little arm to be a little bit longer. So if I go to my design tree and I go to my brake tab, I can edit in place. And so now it'll allow me to mess with this tab inside the assembly. And if I go back to my sketches, I'm going to edit this sketch. And let's make it hit a little bit further down. So what's this? 150? Oh, that's a lot. We can either dimension this angle, or it might be better to dimension the distance. So maybe this distance here, from here to here, and let's call that 120. And let's call this one maybe 15. And we can play around with this so it looks good. 120 is actually a lot. Let's do 110. 100? 110. And again, you could feel free to tweak the aesthetics however you want. So now if we look at it, we can finish editing in place, which will jump us back out to the main assembly. And you can see here, because we made it longer, it has a little bit more contact with the seat stay. In fact, I probably want to make that tab a little bit bigger. So edit in place again, edit sketch, and make this 20. Finish editing, jump back to assembly, hide the sketch. And that looks good to me. So there you have it. That's how you design a IS brake tab and check its clearances.